Hello everyone. We are going to start the last chapter of the geotechnical engineering subject. This is the chapter 9 and name of this chapter is Foundation Engineering. This is the outline of this chapter. So first let us discuss what is a foundation. So a foundation is an element of a structure which connects it to the ground and transfers loads from the superstructure to the ground. And it supports and anchors the superstructure of a building and transmits its loads directly to the earth. And to prevent damage from the repeated freeze-thaw cycles, the bottom of the foundation must be below the frost line. Then let us discuss types of foundation and their uses. So there are basically two types of foundation, shallow foundation and deep foundation, and they are differentiate by their depth of soil in which the foundation is made. For example, like the shallow foundation can be made in a depth of as little as 1 meter or 3 feet, while deep foundation can be made at a depth of 20 to 65 meter. So according to the depth they are categorized. And the shallow foundation is placed immediately below the lowest part of the superstructure. Also it is known as open foundation. The shallow foundation also known as open foundation. And also the shallow foundation, the construction of shallow foundations is cheaper, but the construction of deep foundation is expensive. And the shallow foundation means it has having little depth, as already I have told that its depth up to 1 meter. But deep means extending far away from a point of reference, especially downwards, extending far down from the top or surface. So according to this, they are divided in two types, shallow foundation, deep foundation. Again, shallow foundations are of these types, like individual footing or isolated footing, combined footing, strip foundation, raft or mat foundation. And the deep foundations are of like pile foundation, drilled shafts or caissons. So these are some examples of these types of foundation. So let us discuss one by one. First is the individual footing or isolated footing. So individual footing is the most common type of foundation used for building construction. And this foundation is constructed for a single column and also called a pad foundation. And the shape of individual footing is square size or it may be rectangular and is used when loads from the structure is carried by the column. Here the size is calculated based on the loads on the column and the shape bearing capacity of soil. So we can calculate this based on the load on the column. The next is the combined footing. It is constructed when two or more columns are close enough and their isolated footings overlap each other. And it is a combination of isolated footings, but their structural design is different. The shape of this footing is a rectangle and is used when loads from the structure is carried by the column. So this is the combined footing. Third one is the spread footing or strip footing and wall footing. So spread footings are those whose base is wider than a typical load-bearing wall foundation. And the wider base of this footing type spreads the weight from the building structure over more area and provides better stability. So these should not be used on soils where there is any possibility of a ground flow of water above bearing layer of soil, which may result in score or there is chances of liquefaction. So this figure shows a type of spread footing. Number 4 is the wrapped or mat foundation. These are the type of foundation which are spread across the entire area of the building to support heavy structural loads from columns and walls. And the use of mat foundation is for columns and walls foundations where the loads from the structure on columns and walls are very high. Wherever we saw that the load from the superstructure is very much high, in that case we prefer for this type of foundation like raft or mat foundation, and it is suitable for expensive soils whose bearing capacity is less, for the suitability of spread footings and wall footings. Next is the types of deep foundation. So first is the pile foundation. It is a type of deep foundation. What is deep foundation? Already I have told you. So it is a type of deep foundation which is used to transfer heavy loads from the structure to a hard rock strata much deep below the ground level. And pile foundations are used to transfer heavy loads of structures through columns to hard soil strata which is much below ground level. In that case, we provide this deep foundation like this as shown in the figure. See, this is the ground surface and this is the pile, this is the rock strata end bearing. So up to that depth we have to construct this type of foundation. So it is much more expensive, costlier foundation. So basically we use this type of foundation in bridges, or we can also use this in case of construction of high-rise buildings. This is also used to prevent uplift of the structure due to lateral loads such as earthquake and wind forces. Next is the drilled shafts or caisson foundation like this. Drill shafts, also known as caissons, is a type of deep foundation and has an action similar to pile foundations but are high capacity cast in situ foundations. It resists load from structure through shaft resistance, toe resistance, and or combination of both of these. The construction of drill shafts or caissons are done using an auger like this. This is a figure of auger. By using this, we drilled or we construct drill shafts or caissons like this. So these are all about the types of foundation. Let us discuss the major function of foundation. So some functions are discussed, like first is the reduction of load intensity. As we know, the foundations distribute the loads of the superstructure to a larger area so that the intensity of the load at its base does not exceed the safe bearing capacity of the subsoil, and also the load is evenly distributed through the or by the foundation. Next is the same point, even distribution of load. Foundation distributes the non-uniform load of superstructure evenly to the subsoil. This is the major work of the foundation. Due to this, unequal differential settlements are minimized. The next is the provision of level surface. Foundation provide leveled and hard surface over which the superstructure can be built. Next function is the lateral stability. Foundation anchors the superstructure to the ground, thus imparting lateral stability to the superstructure. And the stability of the building against sliding and overturning due to horizontal forces like wind or earthquake forces, these are the horizontal forces, is increased due to foundation. Next function is the safety against undermining. It provides the structural safety against undermining or scoring due to burying animals and due to for flood waters, etc. Next is the protection against soil movements. Special foundation measures prevent or minimize the distress or cracks in the superstructure due to expansion or contraction of the subsoil because of moisture movements in some problematic soils or in some particular area. So these are the major functions of the foundation, or you can also say that these are the major role of a foundation. So before construction of any work, any civil engineering work, first you have to focus on the construction of foundation. As per our requirement, we design the foundation. Next, let us discuss the bearing capacity of soil. So, bearing capacity is the maximum stress or pressure that a footing can sustain without failure of the soil or rock that is supporting the footing. Also, the bearing capacity is a function of the shear strength, we can also say, of the soil material or rock mass. But it also depends on the size and shape of the footing and the thickness of the soil or rock adjacent to and above the base of the footing. So, obviously, the bearing capacity of soil depends on the size and the shape of the footing. According to the shape or size of the footing, it can bear the load of superstructure or any horizontal forces acting on it. So, geotechnical engineering defines the bearing capacity of soil as the capacity of soil to resist external load applied to it. And in simple terms, it is the capacity of soil to support the load without failure. So, these are some definitions of bearing capacity of soil. So, in next lecture again we will continue this chapter with some discussing some different technical terms related to bearing capacity of soil. Thank you.